Good evening, everyone. I am G.Nanda Phanith, and my mini project is on human facial expression detector. We have done this under the guidance of our Professor Dr. S. Prabhaharan sir. Coming to the project, let's see the abstract. Abstracts give the abstract gives the overall review of how what the project is about. In the abstract, we can see that facial expression plays a key role in nonverbal communication. However, human can communicate nonverbally. Now, computers are getting better at reading the emotions. The emotions are the indicator of one's feeling. The basic human emotions are happy, sad, neutral, surprise, angry, fear. It proposes a set of research scenarios of emotion recognition application in the following domains. The domains are software engineering, website customization, education, and gaming. In this project, we use web camera to analyze the facial expression and detect the emotion, which is cost effective and there is no need of any special equipment. We used a Keras as the open source neural network libraries, which contains numerous implementation of neural network building blocks such as layers, objectives, functions, and optimization. The next is the existing system. The existing system works on a module which helps us to steer towards our project in 30 approaches, which has an accuracy of 56%, which does not manifest for face identification. It could only satisfy the emotion recognition, that too with the high quality of image or face. The limitation of the existing system. Poor image quality limits facial recognition effectiveness. Different face angles can throw off facial recognition reliability. High accurate systems will be expensive due to the use of costly equipments. Validation of emotion dataset is a challenge in order to have accurate emotion recognition system. Proposed system. In proposed system, we used CNN algorithm for the facial emotion recognition. CNN is nothing but conventional neural network. The main goal of this is to identify the facial emotion which are categorized into anger, fear, sadness, disgust, happiness, surprise, neutral. Our project will include downgrading of approaches rate from 30 to 10 for better lucidity. Facial emotion recognition with facial identification would create better outcome, for which Kaggle dataset is extended with Adam Gitti's face recognition library DL/B, whose model accuracy is 99.38%, which is approximately equal to the 100%. System requirement. Two types of requirements we have, that is software and hardware. Coming to the software requirements, we need an operating system of Windows 10 or Mac. The dependencies are NumPy, Pandas, TensorFlow, Keras. The coding language we used in this is Python. The front end is Tinker and IDE is PyCharm. The database we used is MySQL. Coming to the hardware requirements, we required processor of 1.8 gigahertz dual core Intel Core 5th generation. RAM is 8 GB, 1600 megahertz, and hard disk of minimum 128 GB. Next comes the architecture. In the architecture, we can see that two types of stages are present. One is the training stage and next is the testing stage. In the training stage, we need to train how the process need to be, and in the testing stage we need to test the data set. Coming to the UML diagrams, we use the UML diagrams, use case diagram, activity diagram, and the class diagram. Coming to the use case diagram, we can see there are three parts. One, user takes the live detection of the live detection is present or not, and he takes the video detection and then the photo detection. Coming to the activity diagram, user uploads the facial emotion dataset. Then the dataset is pre-processed. Then trained the CNN algorithm with softmax. Then the OpenCV library takes the algorithm and it predicts the facial expression of the user. Coming to the class diagram, in the class diagram, user is the start and predict facial expression is the end of the process. The module we used are data collection and data uploading. Here we need to collect different types of human expression data and we need to upload that. in the data set. The next one is data preprocessing. We need to preprocess the uploaded dataset that is ready for processing. In this module, the dataset uploaded is then preprocessed. That is, dataset is cleaned to remove defects such as anomalies, outliers, noise. So the dataset is ready for the training and provide the better outcomes. Since the data uploaded is usually it's take large time, sometimes to preprocess it, the dataset works perfectly fine while running the algorithm. The next one is training the dataset. In this, we need to train the system how to predict the facial expression of user. Here we run the CNN algorithm and on RNN algorithm button to train the algorithm using the dataset. Once the algorithm has been trained, then it is ready to predict the dataset. Next one is the testing dataset. In this, the trained dataset is being tested in the next stage, that the outcome is given in this testing data. Future enhancement. Recommender system has been an active area of research for a decade or so and continued to be an interesting research domain. Although recommender system has witnessed unpredicted improvements starting from very primitive content based on and collaborative filtering methods. A lot of researchers is going on to further enhance the output accuracy and improve in all dimensions of the recommender system. Due to an increase in data and we need to interact with the computer, the need for the natural language processing is increasing to day by day, and various job opportunities are coming in the market with handsome packages. Therefore, there is a great hope of NLP in the future. The testing cases we use with the testing cases are unit testing, integration testing, functional testing, and the testing methods are white box testing and black box testing. Coming to the testing cases, in the unit testing, the individual units of the components of the softwares are being tested. Coming to the integration testing, the individual units are combined and tested as group. Next, coming to the functional testing is a type of software testing where the system is tested against the functional requirements and specifications of the system. The testing methods are white box testing and black box testing. White box testing is also known as clear box testing, open box testing, glass box testing, transparent box testing, etc., which is a software testing method in which the internal structure, design, implementation of item being tested is known to the tester. Coming to the black box testing is a method of software testing that examines the functionality of an application without peering into the internal structure or working. Next, the output screen of this the project. Here we conclusion. Our experiment for 8 emotional stages, we have achieved a very good classification accuracy of emotions with 57% for random division of data and satisfactory classification accuracy 68 for natural division of data. In the future, the human interaction would be advanced to the emotional intelligence where the machine can detect, react and respond to the humans according to the emotional state of the person. The references. Thank you.